Many people join. Okay, so in the previous class, we discussed about how we can design an eccentrically loaded riveted joint. So the basic procedure is there to solve the problems. What you need to do is first you need to compute what is the center of gravity of the rivet system. You need to compute that. So to compute that, the formulas are your x bar. To compute the center of gravity, first you need to set some origin or some reference for the coordinate system, something like this. Let us say here I can pick either rivet 1 or any one center of any one rivet, center of any one rivet. If I say this is the origin, I'll fit it here, then I'll measure the distances of all the rivets with respect to this one. Then that means I need to find out what is the x coordinate and what is the y coordinate for each and every rivet center. Then I'll use this formula to compute the position of G. That is, okay, since we are assuming all areas of the rivets are same, my formula for x bar is nothing but only sigma xi by n. Sigma n is nothing but the total rivets, number of rivets. Similarly, the formula for y bar is sigma yi divided by n. So these are the formulas. So now using these formulas, first I will compute what is the location of the center of gravity. So after locating this, I need to find out what is the distance of center of each rivet from the center of gravity. So for all the rivets, I need to find out those distances will be denoted by R1, R2, R3 and so on, or maybe C1, C2 or whatever may be the notation. Whether you are following R1 or C1, it doesn't matter. So you need to identify that. Then you need to identify what is the magnitude of primary shear force on each rivet. So that magnitude of the primary shear force is nothing but the total force applied divided by the number of rivets, F by N. So is going to be your primary shear force. So if I take it as F dash or P dash, no problem. So this is going to be the magnitude of the primary shear force, which is same for all the rivets. And also here the direction of the shear force, primary shear force is in the direction quite opposite to your applied force. So if the applied force is vertically downward like this, so therefore it is going to be vertically upward for all the rivets. So this is the primary shear force. Then we need to find out what is the secondary shear force also. So for that we have a formula for computing the secondary shear force. So first we'll compute the C value. C is nothing but your P into E divided by R1 square plus R2 square plus R3 square and so on up to Rn square. So this is the formula what we got for the C. So that we'll use the C formula for C and then we compute the C. Once you got the C, then your F1 double dash, that is the secondary shear force, and the first rivet is nothing but C into R1. Similarly for second rivet, so here if I take F2 double dash is, then this is replaced by R2. Like that, you can calculate all the four secondary shear forces also. Then not only that, you need to not only the magnitude of the secondary shear force, you need to find out the direction of that secondary shear force also. That is, so always the direction of action of the secondary shear force is perpendicular to the line joining center of gravity to the rivet center. So that means here it is perpendicular. So that means I need to draw a line which is perpendicular to this line, perpendicular to this line. This angle is 90 degrees, perpendicular to this angle. So this is 90 degrees. Again perpendicular to this one. This is also 90 degrees. So then the direction is, so you need to consider the arrow here something like this. So all the arrows will rotate in anti-clockwise direction, because here the movement is in clockwise direction, or twisting movement is in clockwise direction. The reaction should be in anti-clockwise direction. So therefore all your arrows of this the secondary shear forces are rotating in anti-clockwise direction. So once I know that, then I need to identify what is the angle between the primary shear force and secondary shear force for all the rivets. So from that, once I know the angle and I know the magnitude of primary shear force and secondary shear force, I can calculate the resultant shear force on each rivet. So once I calculated the resultant shear force in each rivet, so out of all those resultant shear forces, we need to consider the maximum of all these forces, and then we'll use that one as the criteria to find the diameter of the rivet. So once we got this resultant shear force divided by the area and shear. So here all the rivets are in single shear. So I need to take it as 5 by 4 d square into tau. That is the shearing resistance of a single rivet. It should be equal to your allowable shear stress. So from this we can estimate the minimum diameter required for the rivet here. So this is a basic procedure we need to follow. What type of maybe the eccentricity he has given. Okay. So now we'll consider one or two problems on this so that it will be more clear how we can find the diameter. So in that, the first problem what we'll consider is, we'll consider this one as the first problem. So we first note down this problem, then we'll discuss the solution. You take, I think it won't take much time. You take 2 to 3 minutes to note it down, then we'll discuss the solution. So now we note it down the solution. So for this kind of problems, you don't require any data book also. You don't require any data book. Only thing is here we calculate only the diameter. So we are not designing anything here. So the data book uses, of course, if I say data book is not required means don't take it as. So if you don't know these formulas, how to estimate the primary shear force and how to estimate the secondary shear force, if you don't know the formulas, now you can take those formulas from the data book. Those things are given in your data book. If you refer the data book, so these formulas are available. See clearly all these diagrams also he has given. Okay, what I'll do is I'll show you these things to you first. So in which page these are there, then we'll go to this problem. Okay, first what I have to do is I'll come out of the screen presentation. Okay, then I'll turn on the video. Okay. See, this is page number 9.10. You can see that. I'm showing you. If you have a data book, then okay, you can see that. Or else you can see it here. I think it is visible properly, right? Or in reverse manner.
Okay, sir. It's okay.
Okay. So here he has given the eccentrically loaded joint. So a bracket is there. Bracket is connected to some plate through 4 rivets here. He has given the numbering for the rings. So he has given all the notations also here. So this is the force F and this is the eccentricity. So the center of gravity of the rivet system is here, and from the center of gravity of rivet system to the F is he has given it as eccentricity E. So now clearly you can see that he has assigned the coordinate system also here. He has taken this one as the x-axis and this one as the y-axis, and it is intersecting here means this is the origin for the coordinate system. That means this is the reference point to measure x and y values for all these rivets. So once I know the values, then I think that formula may be or may not be given. How to compute the? Yes, it is given here in the previous page. He has given that. See, you can see that here at the bottom here. You can see that eccentrically loaded structural riveted joint, location of CZ. Is it visible? Are you able to read this? Okay, or else if you have data book, you can refer your data book. See, now you can see the formulas here. For the calculation of x bar and y bar, he has given here. X bar is nothing but your x1 plus x2 plus x so on, xn divided by n. Similarly, y bar formula also given here. So where x1, x2 up to x coordinates of n rivets, he has given that thing also here. So that means using these formulas, you can compute you can refer the data book to find out how you can find the center of gravity of rivet system. So once you've done this, then you open the next page. In the next page, he has given the diagrams and everything. So he has shown that and he has given the formulas also here. Induced primary shear load. First sentence is induced primary shear load. That he has taken it as F suffix P. Okay, don't confuse with the notation. So we are taking it as F dash and F double dash. Here he has taken it as Fe, F suffix P, then F suffix S. So primary force as Fp, secondary shear force as Fs. So he has given the formula for Fp also, F by N, where F is the here the applied force. Sometimes you may get it as P also. They will give applied load as P. Don't confuse P or F. It doesn't matter. Whatever may be. If it is a force, as long as it is a force, there is no issue with that. So now we have a formula for primary shear force. Similarly, you have a formula for secondary shear force also. See, you can calculate the primary shear force and secondary shear force. Then if you turn to the next page, so he has given the formula for in first rivet, what is the formula for Fs1? And similarly, he has given the formula for how you can find out the resultant shear force. So this is the formula for resultant shear load. He has given here resultant shear load. This is the formula. Then he has given how we can compute the diameter also. So diameter of the rivet is square root of 4 times R max. That is the maximum resultant shear force divided by 5 into S suffix S. That means tau S. So shear stress in the allowable shear stress in the rivet. So that means if you have a data book, no need to remember. What I want to say here is, if you have a data book, you can use these formulas. No need to remember or mug up those formulas. So you can use the data book to solve the problem. Okay. So that's why I'm insisting for each and every class I'm insisting on the data book. If you have a data book now, this is the advantage. So you can pick the formulas from the book and you can solve the problem. Only thing what you have to learn is you need to learn how we can use those formulas for your problem. So that means how you need to apply those formulas to solve the given problem. That's what only you need to learn in this course. Okay, right. Anyway, so I will go back to the problem again. So now you note it down, then we'll discuss the solution. Okay, so now you note down the problem. A bracket attached to a vertical column by means of 4 identical rivets is subjected to an eccentric force of 25 kilonewtons as shown in figure. Determine the diameter of the rivets if the permissible shear stress is 60 Newton per mm square. So, and he has given the figure of the bracket also. So, you note down that first, then we'll discuss the solution.
completed, sir.
Okay. Okay, so right. So here he has given a bracket which is attached to some plate or wall, whatever it may be. So through 4 rivets. So here in our rivet system there are only 4 rivets are there. So it is subjected to a load of 25 kilonewtons. So and the line of action of this 25 kilonewton force is passing at a distance of 100 mm. So here these dimensions 100, 100, whatever he has given, you take all those mm, all those units are in mm. All the length units are mm. So therefore the offset distance is from the center of the rivet to the load line is 100 mm he has given. So now to find the required diameter for this rivet holes, like what we discussed, we need to follow the same procedure. The first step is we need to identify what is the G, that is center of gravity of these 4 rivets where we need to identify that first. To identify that first, what we need to do is, like I mentioned, somewhere we need to fix our reference thing. So I'll fix the reference coordinate system here. I'll take this one as X, and then this is my y direction. I'll fix something like this. Then I need to identify what is the x coordinate for each rivet and what is the y coordinate for each rivet. So now if I take rivet 1, what is the x coordinate? The x coordinate is only 0. In fact, that is 0 for all the rivets because all these rivets are on y axis. So what is the equation of y axis? Equation of y axis is nothing but x is equal to 0 only. So that means for all 4 rivets, your x coordinate is 0. So now that means your x1 equal to 0, x2 equal to 0, x3 equal to 0, x4 equal to 0. So if that is the case, what is your formula for x bar? Your x bar is nothing but x1 plus x2 plus x3 plus x4 by n. So here it is, sum of those values is 0, 0 by 4, I'll get x bar is only 0. Then coming to the y bar, so we need to compute what is y1 and then what is y2, what is y3,
300, 200,
y4. So what is y1? So from here I need to measure what is the distance of rivet center here. So what is distance y1? So from this point, so here this distance, this total distance what he has given it is 300. So therefore your y1 is 300 mm. y2 is, so this is the center, you need to measure this distance. This is going to be your y2. y2 is 200. Then y3, so distance of center of the third rivet, this is your y3 value. So this is y3, this is y2 and this is your y1. So y3 is 100. Of course they are in mm. Then what is y4? From the center to its center it is 0 only. So now your y bar is sigma y. So that means yi. You need to add up all these things divided by the number of rivets. So if you add all these things, what I'll get? 300 plus 200 plus 100. 600 by
150.
4. So which is number of rivets is 4. I'll get it as 150 mm. From where? From this you have to take, we have taken this one as a reference. So from this point it is at the distance of 150, means where at what location it is? Exactly in between of, at the center of, or in between these two rivets. So from here to here it is 100. So again from this to the center of the rivet 3 to rivet 2 also 100. So exactly at the center I'll get the G here. Okay. So I got the G value. So what is this distance? From this point this distance is going to be 150 or 150 mm. Okay, now I identify the G value. So once I identify the G value, then next what I need to do is I need to identify the R values, that is R1, R2. Here I have four rivets. I need to take four values. R4 I need to identify. So what is the R1 value? R1 is nothing but the distance between center of rivet 1 to the center of gravity. What is this distance now? What is this distance? It is if somebody is there or nobody is there in the class. Nobody is responding. So what is this distance?
150, sir.
Huh?
150.
It is only 150. So then that means, so from this distance you need to take. So this. So you know from this point to this point it is 300. So up to this point it is 150. Then remaining value this is going to be only 150 only. Your R1 is 150. Then R2 means center of gravity of this rivet to this point. So what is this value?
50.
It is again 50 only. So from this point to this point, it is exactly center. So it is 50. Then what is R3 value? That is also 50 only. So we don't bother whether this is positive value or negative value. Simply we consider only the magnitude. Then what is R4? R4 is going to be 150. R4 is also 150. So from G to this one, this center line. So this is also 150 only. So like this, I can estimate what are the values for R1, R2, R3, R4. Then once I estimate that, first I will compute the primary shear force. Whatever he has given in your data book, he has used the notation F suffix P. We'll use the same thing because we whenever you are solving a problem, I will assume that you will use data book. So in that case, even in the data book, your FP is nothing but the given force F divided by N. So what is that value here? 25 divided by 4. So you got it as 6.25 kilonewtons. So in which direction it is going to act? See here it is applied load is acting vertically downward. So here you have a 6.25 kilonewtons vertically upward for all the rivets. For all the rivets it is same and it will act in the same direction. So this is primary force. Primary force, magnitude and direction is same for all the rivets. So then, okay, so that is 6.25, I know that. Then coming to the secondary shear force, to compute the secondary shear force, first we need to compute C. For C is nothing but F into E divided by R1 square plus R2 square plus R3 square plus R4 square. Okay, so you may have a doubt here because the load is in kilonewtons. Here the dimensions are in mm. So in each unit you need to consider R1, R2, R3, whether they are in meters or they are in mm. So you have a doubt. So whatever unit you consider, whether if you want to convert them in meters, you can do that. Or else if you want to substitute as is in mm, you can substitute in mm also, no issue here. So but only thing is whatever constant you got it here, that is Newton for or kilonewton for mm only you are going to get. The units for this is whatever unit consider, so you will get only that in the units. So if I take F in kilonewtons, E in mm, R1 square, R is R1, R is in mm, so Newton mm divided by mm square, I'll get Newton mm. So you can use directly these mm units also. So now in this F is 25 kilonewtons known to us, E is given as 100. From the diagram we can clearly identify that E value. Just now we computed R1, R2, R3, R4 values. So now by substituting all those things, I can compute the C value. What is the C value here? So F is 25, E is 100. 25 into 100 divided by 150 square plus 50 square plus 50 square plus 150 square. So you will get, if you calculate that, you will get C value. So tell me what is that C value now?
Point 0.05 kilonewton per mm.
0.05 kilonewton per mm.
Sir,
Okay, so I got C1.
So 0.05, sir.
0.05.
Yes, sir.
0.05 per mm. Once you have the C value, then your Fs1, that is secondary shear force in first rivet, is nothing but C into R1. So your R1 is 150, C is 0.05. If you compute that, you will get it as 7.5 kilonewtons or 0.75 kilonewtons. 100. So 100 means okay. So 0.05 into 150. How much you are going to get?
7.5, sir.
7.5.
7.5 kilonewtons. 7.5 kilonewtons. Fs1. Then similarly, what is your Fs2? So C into R2. C is 0.05. R2 is 50. You will get it as 2.5 kilonewtons. Same thing you will get this Fs2 is the same as your Fs3 also, because your R2 is same as R3. You will get only 2.5 kilonewtons. Similarly, your whatever your Fs1 is there, that is equal to your Fs4 also. In the fourth rivet also, your R4 and R1 is same. So you will get same thing. So that means in the first rivet you have a shear force of a secondary shear force of 7.5 kilonewtons. In the second rivet you have 2.5 kilonewtons. In the third rivet you have again 2.5 kilonewtons. In the fourth rivet you have a fourth rivet, it is again 7.5 kilonewtons. So once I know that, then so I'll represent that for all the rivets. So now we need to identify what is the direction for that secondary shear force also for each rivet. So now, like I already mentioned, the first direction what you need to do is, I'll rub off all these things. So here, first this is our G here. So you need to draw a line perpendicular to the line joining the G to center of rivet. So it is something like this. Then what is the moment of this load or twisting moment direction for this load about GG? This load is creating a clockwise movement about G. So therefore here the moment of this reaction is going to be anti-clockwise. So I have to take like this. So the moment of the secondary shear force will act something like this. So then it is anti-clockwise, opposite to this one. So that means for the first rivet, if I show those two forces, this force is 7.5 kilonewtons. That is the secondary shear force, and this force is 6.25 kilonewtons. Then if I come to the second rivet, again I have a primary force which is 6.25 kilonewtons, which is acting vertically upward. Then in order to create a anti-clockwise movement, the force should be, secondary shear force should act in this direction, whose magnitude is 2.5 kilonewtons for second rivet. Then if I come to the third rivet, here the primary force is in this direction only, upward direction only, which is 6.25 kilonewtons. Then here if I join this, in order to create the anti-clockwise movement, I cannot take the direction in this direction. So I have to take now in this direction. So because I am taking moments about G here, I have G here, about this point means it should, the direction for this one is like this, and its magnitude is 6.5 kilonewtons, sorry, 2.5 kilonewtons secondary shear force. Similarly, for fourth rivet, your primary force is 6.25 kilonewtons, which is acting upward direction, and then the direction for the secondary shear force is something like this, whose magnitude is 7.5 kilonewtons. So now for all the four rivets, I identify all these things. So now next thing is I need to find out the resultant force. So here it is straightforward only. So one force is acting upward direction, vertically upward, other one is horizontal one. So therefore the angle between these two is 90 degrees. In that case your cos 90 will become 0. So then the only thing is you have to take the square of these two forces. That is, your Fr is nothing but, our resultant force is nothing but square root of 7.5 square, or first I'll write 6.25 whole square plus 7.5 whole square. So this is the resultant force on the first rivet. Similarly, 6.25, I don't need to take these two rivets also, because your Fs is less when compared to this. The angle is 90 degrees only for all the rivets. So whichever is going to the maximum, I can do that. Or if you don't know that principle, you calculate for rivet 2, rivet 3 and rivet 4 also. So only thing is your maximum value is going to be this one. So now I'll equate this one to allowable shear stress. He has given it as 60 Newton per mm square. So therefore finally your equation is 60 is equal to your Fr max divided by 5/4 d square. So now I know everything. So if I substitute that, I'll get the d value. So that's it. That is the solution. Okay. So now I'll show you the solution. That is, already explained the solution. Only calculation part. Now I'll show it to you. So this is what we already expressed here. So P1 dash, here he has taken P1 dash, P2 dash, P3 dash, P4 dash, and also G is marked here. So we already know how we mark, how we got the G position is here. So the magnitude of, okay, here you can see that here also he has marked this, okay, this distance is also marked from the G to this rivet and this rivet. This is 50, this is 50, this is 100 and 100. So based on that, he identify the R values. So then, so primary shear forces are marked and secondary shear forces are also marked here. Okay. So this is the data what he has given. Okay. Now, okay. So the primary magnitude of the primary shear force is nothing but, so 6.25 kilonewtons we have taken, but he has converted that one into newtons. So 25 into 10 cube divided by 4, we'll get it as 6250 newtons. So which is same as your 6.25 kilonewtons. So this is the primary force. Then coming to the secondary shear force, we already identified these values. R1 and R4 is 150, R2, R3 is 50. I already explained that to you. Then he calculated a C. So because he is substituting the new force in newtons, you got it as 50 here. Then if you substitute, you will get P1 and P4 as 7.5 kilonewtons or 7500 newtons. P2, P3 you will get it as 2500 newtons or 2.5 kilonewtons. So once you've done that, then the resultant is, the only thing is here I represent the primary and secondary forces. Here they are making an angle of 90 degrees, then the resultant is going to be this one only. So 9762.81 newtons. So once I find out the resultant force, then I can calculate by equating this P1 to 5/4 d square into tau. So P1 we already estimated, which is 9762.81 is equal to 5/4 d square into 60. If you solve that, you will get the value for D, which is 14.39. We can round it off this one to some 15 mm or 16 mm. So whatever may be the standard diameter, you pick the standard diameter from the data book, you take that one as the diameter for the rivet. So this is how you can solve the problem. Okay, if you want, you can note it down, or else we'll go to the next problem. If anybody want to note it down this one, so here why he has calculated only P1, the explanation is for that also he has given rivet 1 and 4, which are located at the farthest distance from the center of gravity, are subjected to the maximum force. Why? Because the primary shear force is same in all the rivets. So we cannot identify which rivet is subjected to maximum shear force based on primary shear force. Primary shear force is same for all. So then only based on the secondary shear force only we can identify which rivet is subjected to maximum shear force. So since we have taken that expression for the primary secondary shear force is proportional to C into R. So which is going to be the maximum value for R, they are subjected to the maximum shear force. That's what is you can see also in the calculation part of also. Only rivet 1 is subjected to 7.5 kilonewtons of secondary shear force. Rivet 4 is also subjected to a secondary shear force of 7.5 because this distance is 150. Even for this rivet also the distance is 150. So that's why you are getting the same value. So the rivet 2 and rivet 3 they are close to this G value. So that's why they are subjected to lesser secondary shear force. So therefore, based on this statement always, so I can pick this is the rivet I need to use for the design criteria. So the primary and secondary forces acting on the rivet 1 and 4 are right angle to each other. That angle is right angle means it already I told you the angle is 90 degrees. So therefore you can directly use this formula. So our cos theta will become 0. So we can use this formula to compute the resultant shear force. Once you have a resultant shear force, you need to equate that one to the shear strength of the rivet. From that you will get the diameter of that. Okay, so this is how we can solve the problem. So I think we need to consider one more problem so that we can close this topic. In the next class, I am going to start the welded joints. So then we'll move on to the next problem also. Okay, so then this is the second problem what we are going to discuss. So just you note it down. So we'll discuss the solution also. Solution for this problem also. Now number of rivets are here 9. Earlier one it is 4, now they are 9. Okay, so I'll give you 2 minutes to note it down, then we'll discuss the solution also. So this is also a similar problem. Nothing is different, but only thing is here you have a instead of 4 you have a 9 number of rivets. That is the only thing. The approach, everything is same. So the bracket is attached to a steel channel by means of 9 identical rivets as shown in figure. Determine the diameter of the rivets if the permissible shear stress is 16 Newton per mm square. That is the problem. So he has given the diagram of that bracket and he has given the dimensions also. The load is given as 50 kilonewtons, eccentricity is given as 300 mm. Here also take all the length dimensions are in mm. So by taking that you can solve this problem also. Okay, anyway, so I can explain this in 15 minutes. So is it completed?
Yes, sir.
Okay. So now we'll discuss the solution. The first step is you need to identify the center of gravity of the rivet system. So you fix your origin somewhere, wherever you want, you can fix it. It's not an issue. So only you need to take this rivet or this rivet as a reference. You can take any rivet center as a reference. Let us say I'll take this one as my reference. So this is my horizontal axis, or x-axis. This is y-axis. This is x. This is y. So now you know now from the given dimensions you can easily identify that what is the x coordinate, what is the y coordinate for all the 9 rivets. So let us say if I want to take the first rivet, its x coordinate is 0, y coordinate is 200. For rivet 4, x coordinate 0, y coordinate is 100. For rivet 7 it is 0, 0 because its center is coinciding with the origin of the reference coordinate system. For rivet number 8, rivet number 8, x is 100, y is 0. For 9, x is 200, y is 0. For 5, it is 100 and 100. For 6, it is 200 and 100. For 2, it is 100 and 200. For 3, it is 200 and 200. So like that, you can easily identify that. So it's not a big deal. So then once you have the x-axis and y-axis, you can easily calculate the center of gravity also. So using that formula you can do it. So instead of doing that, if you know the concept of symmetry, straight away you can easily find out the center of gravity. So now if I draw a horizontal line here, so your rivet system is symmetric about this axis. That means whatever you have on the bottom side, the same thing you have on right side. That's what I'll call it as a symmetry. Similarly, if I draw a vertical line through the center line of the second row, then whatever you have on the right side, the same thing is going to be on the left side also. So that means, so this is symmetric about this axis also. If it is symmetric about two axes, then intersection of those two symmetric axes is going to be your g values. Right away I can write this is going to be the g. I can estimate something like this also. Instead of taking the reference coordinate system, doing all these things, so based on the symmetry I can easily identify this value. So once I fix the g value, now we need to identify what are the, so this is going to be the g. So rivet center 5 is going to be the center of gravity of all these 9 rivets. Then you need to identify what is the R1 value. So this R1, so this distance you need to find out. R1 is nothing but, so here directly you won't get it here, but only thing is, you know this horizontal distance, this is 100. You know this distance, this is also 100. So then use Pythagoras theorem to find out. So it is something like a right angle triangle, something like this. You need to find out what is this hypotenuse. That is nothing but square root of 100 square. This is 100 and this is 100. Square root of 100 square plus 100 square. You will get that value. Similarly, for this rivet, it is 100 only R2. For this rivet, it is square root of 100 square plus 100 square. For this rivet, it is only 100. For this rivet, it is only 100. For this rivet also it is 100 only. For this it is square root of 100 square plus 100 square. For the 9th rivet also it is square root of 100 square plus 100 square. So out of all these rivets, only R3 value, R1 value, R7 value and R9 value is equal. That is your R1 is equal to R3 equal to R7 equal to R9. And what is that value? That is square root of 100 square plus 100 square. That means root 200. Root 200 is nothing but 140, 1.74. force something you will get. That is R1, R3, R1, R3, R7, R9. Then R2, R6, R4, R8. Remaining thing they are going to be only 100 mm only. Your R2, R6, R4, R8, they are 100. So now I know R values for all the rivets. So then once I know all the R values, first I'll compute the C value. C is nothing but this F, that is 50 kilonewtons into 300. Anyway, I convert this one is also newtons because here your allowable shear stress is in newtons. You convert this is also in newtons. So that is 50 into 10 cube into your E is 300. Divided by, just now we computed this all values. So R1 square plus R2 square up to R9 square, I'll get C value. Once I get the C value, then, so I don't estimate the forces in the rivets 2, 4, 6, 8. Why? Because they are close or they are having R values smaller than these values, these for these 4 rivets. So I will compute only R1, R3, R7 and R9. So again here, this distance, that is R1 is equal to R3 equal to R4 is equal to R9. So then whatever values the secondary shear force I am calculating, if I calculate that for the rivet 1, that is sufficient. That is same as for rivet 3, rivet 7 and rivet 9 also. So that is nothing but your C into R1. I got the secondary shear force. Once I got the primary shear force and secondary shear force, then I need to identify the direction for that. So here, the primary shear force for rivet 1, it is vertically upward. Even for rivet, all rivets, it is vertically upward only. But I am showing only for these 4 because these 4 are subjected to maximum force, so maximum shear force. So 1 and 1379 only we consider. So these are the subjected to the maximum shear forces. So therefore, this is your FP direction. If you come to the FS, so here this is a line which is joining this. I need to draw the perpendicular to this one. So then here this is creating a clockwise movement. So therefore I have to take the arrow at something like this. So then I need to estimate what is this angle. So to estimate this angle, I know here this angle is 45 degrees only because this is 100 he has given. Even this is also 100. If I apply tan theta formula, 100 by 100 it is 1. So tan theta is equal to 1 means your theta is 45 degrees. This angle is 45 degrees. So that means if I take a real line, this angle is 45 degrees or this total angle is 135 degrees. So I know the theta 1 value. Similarly, if I take the third rivet here, so in order to identify the direction, so I need to draw a perpendicular to the line joining rivet 5 center to the rivet 3 center. Then in which direction it has to create? It has to create in a clockwise, the movement is in clockwise. So it has to create a anti-clockwise direction, so movement. So therefore I need to take something like this. So here this angle is 45 degrees, I know that. Because here also this angle is only 45 because this distance is 100, even this distance is 100, this angle is 45. If this angle is 45, even this is also 45. Similarly for rivet 7 also, here I need to draw the line perpendicular to these 2 centers, something like this. So in order to have it is a anti-clockwise direction, I have to take secondary shear force direction is something like this. Then what is the angle between these 2? Again it is 135 degrees. So now for the rivet 9, the secondary shear force is, it is something like this. So the angle here it is 45 degrees. So therefore, like already told you, always you need to consider the rivet having less theta value. So here your FP and FS, these are same for all the 4 rivets, but if you compare that, so this rivet 3 and rivet 9 is subjected having less theta values. So therefore your maximum shear force is corresponding to either F3 rivet 3 or F9. So you need to compute only F3 or F9. So then these 2 are same only. Your F3 and F9 will become only equal. So once you got the F3 value, then equate this one to the shearing strength of the rivet, that is 5 by 4 d square into tau. So from that you will get the diameter of the rivet. So that's it. That's how we can solve this problem. Even though you have a 9 number of rivets, so finally we are calculating only the force at rivet, either at rivet 3 or rivet 9. From that we are getting the solution. Okay, now I'll show you the calculation part here. So these are the given data what he has given in the problem. Then, so directly straight away, primary shear force is nothing but the applied force 50 divided by the number of rivets. Here the number of rivets is 9, so I'll got it as 5555.56 newtons. That is the primary shear force, which is same for all the rivets. Then the secondary shear force is by symmetry. The center of gravity is located at the center of rivet 5. Like that, I already told to you. The radial distances of rivet centers from the center of gravity are as follows. So only for rivet 5 it is 0. For 2, 6, 8, 4 it is 100 mm only. I told that. For 3, 1, 3, 7, 9 it is 141.42 mm. So therefore, since this distance is maximum, only these 4 rivets, rivet number 3, 9, 7, 1 are subjected to the maximum secondary shear force. So therefore, I can ignore these rivets to compute the secondary shear force. But before that, we need to compute the C value. To compute the C value, we require all these values. So now, okay, so I'll compute the C value. So tan theta is 45 degrees only. So here you can clearly see that. So here join for rivet 3 to the center of gravity here. So this vertical height is 100. Even this horizontal height is also 100. So therefore, this tan theta is nothing but 100 by 100. You will get only. So that's what here written. Tan theta is 100 by 100. So from that you will get theta is 45 degrees. Then he estimated the C value P into E. Okay, here P is your 50 kilonewtons, 50 into 10 cube, and the eccentricity is 300 divided by R1 square to up to R9 square. So in that 4 are equal. So that's why he has taken it as 400 square. That is these 4. Okay, here also it is there. These 4 are 100 only. So 4 times 100 square I can take, and for this I can take, for these 4 rivets I can take 4 times 141.42 square. Of course, this R5 is 0 means I'll get only 0 here. So if I simplify this, I'll get C is equal to 125. Once I got the C value, then C estimated the force at the 3 rivets. So that is P3, P9 and P6. See, out of all these 3 also you can see that P3 and P9 they are same, because the distance of R is same. So you got P6 is you got the less value. So therefore we won't consider this also. Like that I have already told to you. Only we'll consider 1, 3, 7, 9. Out of these 4 also only P3 and P9 will consider. Why? Because the theta value is smaller and compared to 1 and 7. So that is only 45 degrees theta value. So I'll choose either P9 or P3 as the my value, maximum value. So then, okay, you have chosen P3. So then, using that, you can calculate the resultant force also. So you can use that formula. He has used a different formula here, or else you can use the same formula. That is P3 dash, whatever there in your data book, P3 dash whole square plus P3 double dash whole square plus 2 P3 dash P3 double dash cos theta. So this is the formula what is there in the data book. You can use this one under square root. You need to apply the square root. So these things both are same only, in different format he has given. So both are same only. So if you do that, you get our resultant force is 21,960.1 newtons. So this is the resultant force we need to use to compute the diameter of the rivet. So see P6, okay, I already eliminated that. No need to calculate this one because only this is the maximum value you are going to get. So anyway, I have shown that calculation also. If you want, you can calculate that, but it is not required. Only thing is the design is based on this value only. See now, your P3 is equated to the shearing strength of the rivet. So from that you will get the diameter. So 21.59 you will get if you calculate it. So that it can be rounded up to the 22 mm. So like this you can solve the problem. Whether you have a 2 rivets or 4 rivets or 9 rivets or maybe for that matter any number of rivets, the procedure is going to be like this only. So you can solve the problem like this. So this is what I want to discuss in case of this eccentrically loaded riveted joints. Okay. So with this we can close this topic also. That means the riveted joints topic is over now. Next we'll move on to the welded joint. That will start in the next class. So still we have 5 more minutes time is there. If you want to note it down, you can note it down, or else if you have any doubt, then we can discuss your doubts also. So that is left to you. First, I'll give the preference for the doubts. If you have any doubt, then you can ask. Then, if you don't have any doubt, if you want to note it down, you can note it down. It's not issue. You tell me if you have any doubts first. Only 58 members, not only 58 also, only 56 members are there in the class. I'll see how many of you given the attendance. 61 is given the attendance. Given that 56, so what happened to those remaining 5 people? The same persons, what I called in the previous class. Today he was there. Mr. Bal Subramaniam, 38.
Yes, sir.
In the class attend అయ్యావా నువ్వు?
Yes. Attend అయ్యా సార్ 4:30కి లాగ్ అటెండ్ అయ్యా సార్.
అటెండ్ అయ్యావా? మరి నేను పిలిచేయడానికి నువ్వు క్లాస్లో లేవుగా.
4:30కి అటెండెన్స్ ఇచ్చి వెళ్ళిపోమన్నారు కదా సార్, అప్పుడు వెళ్ళిపోయా సార్ అటెండెన్స్ ఇచ్చి. 4:30కి అటెండెన్స్ ఇచ్చి లాగౌట్ అవ్వమన్నారు కదా సార్, అప్పుడు లాగౌట్ అయ్యా సార్.
అంత ముందే అడిగా కదరా నేను లాగౌట్ అవ్వకముందే అడిగా, నేను పిలిచా నిన్ను క్లాస్లో ఉన్నా అని. అప్పటికే లేవు నువ్వు.
లేదు సార్, లేదు సార్ 4:30కి అడిగారు సార్ మీరు నన్ను. 4:30కి అడిగారు సార్ మీరు నన్ను.
ఒరే రికార్డెడ్ వీడియో ఉందిరా, ఆల్రెడీ ప్రతి క్లాస్ రికార్డ్ చేస్తున్నాం కదా మనం.
అవును సార్, కరెక్టే సార్. నేను 4:30కే లాగౌట్ అయ్యా సార్, మీరు నన్ను అప్పుడే పిలిచారు సార్ అటెండెన్స్ అయ్యాక.
అటెండెన్స్ అయినాక నేను చెప్పిన దానికి నువ్వు ఎందుకు వెళ్ళిపోయావు? మరి ముందే ఎందుకు వెళ్ళిపోయావు నువ్వు క్లాస్ నుంచి? క్లాస్ క్లోజ్ చేయలేదు.
మీరు పౌల్ ఇచ్చి లాగౌట్ అవ్వమని అని చెప్పి లాగౌట్ అయ్యారు.
లాగౌట్ అయిపోండి ఎవరు? నేను చెప్పాను
అటెండెన్స్ పౌల్ చేసి లాగౌట్ అవ్వమని.
నేను లాగౌట్ అవ్వమంటే
చెప్పారు సార్, అటెండెన్స్ అయిపోయాక లాగౌట్ పౌల్
లాగౌట్ అవ్వనరా అని చెప్పినాక మళ్ళీ మిమ్మల్ని ఎందుకు పిలుస్తాను నేను?
అటెండెన్స్ ఫోల్ చేసి డౌట్స్ ఉన్న వాళ్ళు ఉండండి, అయితే వెళ్ళిపోండి అని చెప్పారు సార్ మీరు.
నేను ఆ వీడియో చూద్దాం, రికార్డింగ్ ఉందిగా, వీడియో రికార్డింగ్ ఓపెన్ చేస్తా కావాలంటే చూద్దాం, విల్ సీ దట్. సో నాకున్న డౌట్ ఏంటంటే నువ్వు క్లాస్ అటెండ్ అవ్వట్లా ప్రాపర్గా, అవునా కాదు?
నేను 4:30 వరకు ఉన్నా సార్ లాస్ట్.
నువ్వు ప్రాపర్గా క్లాస్కి అటెండ్ అవుతున్నావు లేదా? దానికి సమాధానం చెప్పు నాకు.
అటెండ్ అవుతున్నా సార్, 3:50 నుంచి క్లాస్లో ఉన్నా సార్. నేను
3:50 నుంచి క్లాస్లో ఉన్నావా?
క్లాస్లో ఉన్నా సార్ 4:30 వరకు.
ఏం చెప్పావు నిన్న?
4:30 వరకు క్లాస్లో ఉన్నా సార్, 3:50 నుంచి.
ఓకే, నిన్న క్లాస్లో ఏం డిస్కస్ చేసావు చెప్పు. టాపిక్ పేరు చెప్పలేదు, మొత్తం టాపిక్ చెప్పక్కర్లేదు కానీ చెప్పు.
క్లాస్ స్టార్టింగ్ లో సమ్ చెప్పారు సార్. క్లాస్ స్టార్టింగ్ లో సమ్ చెప్పారు సార్.
ఏ సమ్ చెప్పాము? దేని మీద చెప్పాము సమ్?
చెప్తున్నా సార్, రివర్స్ మీద చెప్పారు సార్.
ఏంటది? రివర్సా?
సమ్ చదవనా సార్?
సరే చదువు.
సమ్ చదవమంటారు సార్.
వద్దులే.
థియరీ పార్ట్ చెప్పారు సార్.
ఏం చెప్పాను థియరీ? టాపిక్ పేరేంటి?
ఎసెంట్రికల్ లోడెడ్ రివిటెడ్ జాయింట్స్ సార్.
ఓకే, నోట్ చేసా అంత అయితే?
నోట్ చేసా సార్.
లేదా వేరే వాళ్ళు వాట్సాప్ చేస్తే దాంట్లో చూసి
నోట్ చేసా సార్.
వేరే వాళ్ళు ఇచ్చిందని తీసుకుని చెప్తాను.
లేదు సార్, నోట్ చేసా సార్ నేను. లేదు సార్, నేను రికార్డింగ్ లో కూడా ఉన్నా సార్, చూడండి సార్ కావాలంటే.
సరే చూస్తాలే, అంటే రికార్డింగ్ లో అది రాదు కానీ ఉంది లేదు నేను చూసేది నాకు కనిపిస్తుంది కదా. రికార్డింగ్ లో ఏమవుతుంది, అంతసేపటికి
నోట్ చేశాను సార్, నోట్
స్క్రీనే ఫోకస్ అవుతుంది. ఎప్పుడు అయితే నేను నిన్ను పిలిచానో అది కూడా ఆ టైం కూడా రికార్డ్ అవుతుంది. నువ్వు ఏ టైంలో ఉన్నావో ఏ టైంలో ఉన్నావో అది కనిపిస్తుంది దాంట్లో. ఓన్లీ నేను నిన్ను పిలిచినప్పుడు ఇక్కడ లిస్ట్ లో చూస్తే నేనేం లేదు, అది వరకు రికార్డ్ అవుతుంది, అంతవరకు రికార్డ్ అవుతుంది అంతే. ఓకే, సో నా ఇంటెన్షన్ ఏంటంటే రెగ్యులర్గా క్లాసులకు అవ్వమని చెప్పడానికి నేను అడుగుతుంది ఇదంతా. సో నిన్ను పట్టుకొని నీదేదో ఇన్వెస్టిగేషన్ ఇదేదో చేద్దామని కాదు.
ఓకే సార్.
రైట్. సో ఈరోజు ప్రాబ్లం అర్థమైందా మరి ఈరోజు ప్రాబ్లమ్స్?
సార్
అర్థమైంది సార్.
ఎగ్జామ్లో వస్తే సాల్వ్ చేయగలగదా?
అర్థమైంది సార్.
ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూలో సాల్వ్ చేయగలగదా అంట.
చేస్తా
సో సేమ్ థింగ్ బోల్టెడ్ జాయింట్స్ లో కూడా ఇలా ఇదే ప్రాబ్లమ్స్ ఉంటాయి, ఇలాంటి ప్రాబ్లమ్స్ ఇక్కడ
చేస్తా.
నేర్చుకుంటే అక్కడ కూడా ఉపయోగపడుతుంది మీకు. ఓకే రైట్. ఓకే
Okay.
ఓకే సో రైట్. సో ఐ థింక్ నౌ ఇట్ ఈస్ ఆల్రెడీ 12:45. సో డౌట్స్ ఉంటే ఓకే, లేదంటే డౌట్స్ లేని వాళ్ళు అటెండెన్స్ ఇచ్చి లాగౌట్ అవ్వండి. యూ కెన్ గో, యూ కెన్ లీవ్ నౌ. అట్లానే కొంతమంది క్లాస్లో జాయిన్ అయ్యి అంతే ఉంటారు, లాగౌట్ అవ్వడం అని కూడా ఫోర్స్ఫుల్గా లాగౌట్ చేయాల్సి వస్తుంది వాళ్ళని. వాళ్ళు ఏంటంటే ఆన్ చేసేసి వెళ్ళిపోతారు అంతే. What happened to these people? Bhava, Teja 315, 327, Raman and 354, Vikas Das and LE8 Joseph. ఈ క్లాస్లో ఉన్నారా నాన్న? ఇక్కడికి వెళ్ళిపోయారా?